Good day everyone, I am Shelo Pimelo, your discussant for today, Chapter 10, Section 10.3, Measure of Variability. So, the mean, median, and the mode provide us with a glimpse of the distribution of scores. However, these pictures is incomplete and can sometimes mislead us. So, let us consider a set of score 4, 5, 6, 4, 2, 7 that has an age or mean of 2 and a set of scores 9, 8, 10, 11, 8 which also has an average of mean of 9.3. So, if the average will be the only basis, one might think that both sets are the same. Thus, in the first set, one might be led to believe that the average the scores cluster on the value 92, when in fact the scores are lower than that for most of the times except the score 27, which is an extremely high score or outlier. So, an outlier distorts the picture of the distribution. Thus, we need other measures such as the measure of the scores variability to paint a clear picture of the data set. A. The range. The range is easier to compute since it is just the difference between the highest and lowest scores. R equal highest score minus lowest score. The advantage of the range is it's easy of computation. However, its saying disadvantage is the limited information that provides given the lowest and highest scores. The range only provides a raw state of variability. So, example, it's set of scores 4, 5, 4, 27. Computing the range yields a value of 23, which is a very high one considering that the highest possible score is just 95, but looking at the distribution, significantly more scores range from 4 to only 1 and outlies it's beyond that range. So, the range therefore is clearly influenced even by just one score or one student. B. The mean deviation. One problem of the range is that it only utilizes 2 scores. So, this is solved by computing for the mean deviation. Therefore, the mean deviation is just the mean of the deviation of each score from the mean. However, if you add all the deviations and you include the plus and minus signs, it will also be equal to 0 because we take only the absolute deviations, because absolute value diagram the positive and negative signs. We can compute for the sum of the derivations and divide it to the total number of scores. B. The mean deviation. Here's the example. Determine the mean deviation of the set of scores 25, 27, 28, 19, 18, 17, and 20. Step 1. Determine the mean of the distribution. 25 plus 27 plus 28 plus 29 plus 18 plus 17 plus 20. 17 equal 22. So, step 2, subtract the mean for each row score. So, subtract ang mean for each taga-isa sa row score. So, 25 ang score 25, 27, 28, 19, 18, 17, 20. So, isubtract na siya. Then, step 3, disregard the signs. Take only the absolute values. Step 4, determine the sum of all the deviations. So, here's the picture. Makita na to sa picture sa step 4. So, step 5, divide the sum of all deviations by the number of scores involved, n. So, mo ni ang formula. MD equal 28/7 equal 4. Following the procedures for computing the mean deviation, we arrive at the finding that the mean deviation is 4. This means that on the average, the squares deviates from the mean by 4 points. The mean deviation avoids the problem of ending with a zero value when adding all the deviations by not including the sems, positive and negative. However, it becomes a disadvantage because the absolute values make advanced statistical analysis of the data relatively challenging.
Hello everyone, I am Melissa Nerlin Jimelo and this is the continuation of the section 10.3 measure of variability. In letter C, the variance solves the problem with the mean distinction by getting the mean of the square deviation instead for the absolute value of the deviation. Squaring the deletions gets rid of the negative sign which make it possible to avoid getting a value of 0. When summing of the deviation, it is also more amenable of advanced statistical analysis. This is the formula of the variance. Here's the example. Determine the variance of the set of score 25, 17, 28, 19, 18, 17, and 20. And step 1, determine the mean of the distribution. And step 2, subtract the mean for each row score. Step 3, square each deviations and then get the sum of the square divisions. And the step 4, divide the sum of all square division by the number of score involved. Following the procedure for computing the variance, we arrived the value 17.71 by looking at the resulting value. We can observe the seeming disadvantage of using the variance as a measure of variability because it is expressed as the square of the original unit or the square average deviation from the mean. It becomes relatively hard to visualize the dispersion of score when present with the value of the variance. A result to this is to get the square root of the variance to return to original units. This is now the standard deviation and will be discussed subsequently. In letter D, the standard deviation. The standard deviation, just like the mean deviation and the variance, shows the dispersion of scores around the mean. But unlike variance, it retains the original unit of the data set of scores. It is actually the square root of the variance. Thus, the formula for computing standard deviation. This is the formula of the standard deviation. Determine the standard deviation of the set of score 25, 27, 28, 18, 19, 17, and 20. And determining the standard deviation, calculate the variance first and determine its square root, and this will be the standard deviation. The example either the compute variance is 11. This is how to compute standard deviation. This means that on the average, the scores deviate from the mean by around 4.2 points. And the lastly is coefficient of variation. When comparing variation between set of data, the measure of variation such as the range, mean deviation, variance, and standard deviation will only be useful of the units and nature of the sets of data are approximately the same. In case when we have to compare the scatter of one distribution with the scatter of another distribution. We can use the coefficient of variation. The coefficient of variation is a percentage and utilize the mean and the standard deviation of the distribution. It also is easy comparison since percentage are unitless. This is the formula of the coefficient of variation. Example: two sets of tests were administered to a group of industrial arts students. The first test was a 40 items test in principles of teaching, while the second was a 50 items test in educational technology. The result of the first test revealed that the mean score was 35 with standard deviation of 8, while the mean score for the second test was 43 with a standard deviation of 7. Which of the tests have more variability? So next is, by using the formula, we calculate the CV or coefficient of variation for each set of the test scores. So based from the computing, the scores of the students is the test in educational technology are less varied compared to that of the principle of teaching. That would be all in the section 10.3 measures of variability. That's all.